Welcome to today's explainer. I want you to picture this for a second. A massive, towering machine just waiting out there on the launch pad. The countdown hits 0, the engines ignite, producing this enormous, blinding plume of hot exhaust. The ground literally shakes, and then slowly and then very, very rapidly, this colossal structure just ascends into the sky. It's a sight that honestly never gets old. But looking at this incredible display of power, we really have to stop and ask ourselves a fundamental question.
Right? How does a machine this heavy actually manage to escape Earth? We are talking about millions of pounds of metal, complex machinery, and highly volatile fuel, all fighting against the relentless, invisible pull of Earth's gravity. It is an absolutely immense physical challenge. Getting off the ground requires an unimaginable amount of upward force. So how do engineers actually pull this off? Well, let's dive right into it.
Section 1. The Launch Pad Dilemma. Overcoming gravity. Okay, so to go up, you literally have to push down with incredible violence. We're talking about generating enough thrust to overcome the sheer weight of the vehicle itself. And to do that, you need a very specific explosive chemical reaction. It all starts with your propellants. You take a fuel, you mix it with an oxidizer. When you combine those two and add a spark, you get extremely hot gas. But here's the thing, hot gas alone doesn't magically get you to space. The real magic happens when you force that expanding hot gas out of a highly confined space, creating a high-speed exhaust. That violent ejection of mass downward, that is what creates the upward thrust. It's all about throwing mass in the opposite direction you want to go. But to really wrap our heads around how this happens on such a gigantic scale, we need to look under the hood. Moving on to Section 2, Anatomy of a Rocket. Inside the machine. If we strip away the outer skin of the rocket, we see a layout that's dictated purely by physics. Starting from the very top, you've got your payload, so that's the satellite or the crew, basically the whole reason for the trip in the first place. Right below that sits the brains of the operation, the guidance and avionics systems. Then, taking up the vast majority of the rocket's internal volume are the giant propellant tanks. You've got one for the oxidizer and one for the fuel. Below those are the massive pumps, the combustion chamber where the actual fire happens, and finally, that iconic engine nozzle at the very bottom. It's essentially an exercise in extreme fluid dynamics. Let's trace the actual journey of those propellants, because this is the heartbeat of the rocket. The fuel and oxidizer, they don't just gently mix together. They are violently forced by high-pressure turbo pumps into the combustion chamber. Just to put that into perspective, we are talking about pumping swimming pools worth of liquid in a matter of seconds. Inside that chamber, they undergo controlled combustion, creating this intensely hot, high-pressure gas. Now, this gas has nowhere to go but down, so it flows through that bell-shaped nozzle. And that nozzle is perfectly, meticulously designed to expand and accelerate the gas to unbelievably high speeds right as it exits as exhaust. So, the crucial takeaway here is how this entire engine functions as a massive energy converter. You start with raw chemical energy, sitting quietly stored in the fuel and oxidizer tanks. The combustion process ignites that, rapidly converting it into thermal energy, just intense, blistering heat. The nozzle then physically channels all that heat and pressure, accelerating the gas to convert it into kinetic energy, which is the energy of motion. And that massive kinetic energy directed downwards is what ultimately gives you your upward thrust. Which brings us to the core physics principle at play here, and I really want to use this moment to shatter a very common myth. A lot of folks think a rocket goes up because the flames are somehow pushing against the ground or pushing off the air beneath it. That is completely false. It all comes down to Newton's third law. For every action, there is an equal and opposite reaction. The rocket pushes the exhaust gas backward at tremendous speed, that's the action, and therefore the gas pushes the rocket forward, that's the reaction. It moves purely by throwing mass backward. It doesn't need air to push against at all. Section 3, Surviving the Vacuum. Operating in space. And honestly, it is a very good thing it doesn't need air to push against. Because as our rocket ascends, the atmosphere quickly thins out and completely disappears. This presents our next major engineering hurdle, surviving and actually operating in the total vacuum of space. Think about a standard jet engine on a commercial airplane. A jet engine breathes Earth's air. It scoops up oxygen from the atmosphere to burn its jet fuel. But if you were to take that jet engine up to space, it would instantly choke and die because it's completely starved of oxygen. A rocket engine, however, doesn't rely on the outside world at all. This is exactly why a rocket equals fuel plus an oxidizer. Bringing its own oxidizer to the party is the crucial evolutionary leap that separates a true rocket from a jet airplane. Because the rocket carries both necessary parts internally, it can just keep firing its engines violently, even out in the dead, empty vacuum of space where there is absolutely zero oxygen. But wait a second. If you're up there in a vacuum, you have no air resistance, you don't have wings or rudders to steer with. So how on Earth, or rather off Earth, do you actually turn? Well, you use something called thrust vector control. Since the thrust is what's pushing the rocket, if you slightly pivot the engine nozzle itself, you change the direction of that thrust. By tilting the nozzle just a few tiny degrees, the entire massive rocket tilts. Onboard guidance computers, which use incredibly precise sensors and gyroscopes, are continuously monitoring the vehicle and pivoting those engines to steer it flawlessly through the vacuum.